Good day to our dear listeners from all around the world, and welcome back to the Unveil the Future podcast season 2. My name is Van Nguyen, and it's been a pleasure to be your host, to accompany you through this journey to discover the cutting-edge technology all around the world. And as our journey now comes to an end for this final episode, it is with our pleasure that we welcome Dr. Filippo Giorgi, the globally recognized authority in climate science and also one of the newest members of the VinFuture Prize Pre-Screening Committee. Dr. Giorgi currently serves as the Emeritus Scientist at the Abdus Salam International Centre for Theoretical Physics in Trieste, Italy, where he had previously directed the Earth System Physics section for nearly 2 decades. His work has seamlessly bridges the gap between scientific inquiries and societal needs, emphasizing not only the challenges ahead, but also the innovative collaboration guiding us towards the solution. Join us today as we explore his scientific journey, delve into the latest innovative climate science, and also hear his call to action to all the younger generation. Good morning, Dr. Giorgi, and it's a pleasure to be with you today. And as the newly appointed member of the VinFuture Prize Pre-Screening Committee, how do you perceive the prize role in identifying and amplifying breakthrough scientific innovation with global impact?
Yeah, the VinFuture Prize is quite unique, I think, because it's, at least to my knowledge, it's a unique blend of looking for scientific excellence and innovation, and as well the global impact of this research. I actually don't know of other prizes as big as the VinFuture Prize who focus on both aspects. There are, of course, prizes like the Nobel Prize or whatever that focus on scientific excellence. There are other prizes that focus on the impacts on society. But to me, the unique aspects is that you have both. And so I actually feel very honored to be in the pre-screening committee for this very, very important prize.
And I wonder what aspect of the VinFuture Prize missions, particularly its focus in equity and inclusive scientific advancement, mostly resonate with you, and how do you feel to be a part of this initiative?
Yeah, I think this is a very important aspect because, of course, especially in science, often there is a big favor towards, more richer countries that have maybe a longer tradition with research, but there are new countries coming up. There are young people coming up, especially in science. Traditionally, women have not been in large numbers, but this is actually changing. I think there are many, especially young women coming up with brilliant ideas and new ideas, and especially scientists from developing countries. Of course, the situation in developing countries for research is not easy. I know this very well because as part of the mission of my institute is to foster research in developing countries. So I've seen the conditions in which they work, and very often it's not easy. But I see people that are very eager to learn. So I think it's very good that this prize also recognizes emerging fields and gender issues and developing country issues, and this makes me even more honored to be in the pre-selection committee for this important prize.
And from your viewpoint, what potential does Vietnam hold as a rising hub for scientific innovation? And how might initiatives like the VinFuture Prize or efforts from Vingroup might catalyze a broader transformation in the region's research ecosystem?
Actually, I've been in Vietnam 2 times because I have some collaborations with some Vietnamese scientists. I co-organized some workshops there, so I taught in these workshops, and actually I was very impressed by the thing that most impressed me, I have to say, is you have many young people that are very eager to learn and to grow from the scientific point of view, and very highly technologically advanced. I would say even more than Europe in many ways. So I can see that the there may be a shift in research from the Western world to the Eastern world, because I see that in East Asia especially, there's a lot of motivations to grow and to improve, and there are many problems to solve. So I can see that in the future, the balance of research will probably change, going more towards what we call developing countries. But as you say, I think Vietnam is quite developed, at least from the technological point of view. Yeah, I think this can actually be very important. One reason is that it will foster collaborations between important scientists in the more industrialized countries and Vietnamese scientists, because I can see that there are some very prominent scientists in the pre-selection committee and in the selection committee. So having these people come to Vietnam and talk to your researchers, especially young researchers, and to motivate them, I hope, for example, that I can play that role as well. I think this will be very important to foster the growth of science in Vietnam. Also, I think being a private foundation maybe gives it a bit more freedom, a bit more flexibility to do things, and so this can be actually quite important in catalyzing research and especially collaborations between important scientists in the West, let's say, and growing scientists in the East.
Yes, and now let's talk about you. Your career has spanned through critical decades in the evolution of climate science. So how did the scientific landscape look when you first entered this field, and what inspired you to focus specifically on regional climate modeling?
Yeah, this is a very good question, actually. I have to say that I've had a very interesting career. For one thing, because I always worked on issues that were, at the time when I worked on them, they were very important issues. For example, I did my PhD dissertation in the mid-80s. And one issue that was very important back then was the issue of nuclear winter. Nuclear winter is the climatic effects in the aftermath of a major nuclear war. Back in those days, of course, the Cold War was still going on. There was still a division between the Western Bloc and the Eastern Bloc. And there was a lot of fear that, there might be major war, even with the use of nuclear weapons. Hopefully this, fortunately this never happened, but this issue of what would be the effects of such a big number of explosions in the injection of massive amount of aerosols in the atmosphere on the global climate, this was a big issue back then, and it was called nuclear winter because all this particulate material would block the sunlight and so would throw the surface of the earth in a perennial winter, very cold conditions and very dark conditions. So for me, I was very young. I was working on aerosol physics, and I developed a microphysical scheme for the first interactive climate aerosol model that were used. So it was very, very nice for me to work on something very new and very important. There were many debates about this. Of course, then the Berlin Wall fell, so the Cold War ended. So I remember my advisor told me that nobody was interested in the nuclear winter issue anymore because there was no danger of a nuclear war anymore. But those were the years in the early 90s where the debate about global warming was starting. So I got involved in this, and especially, as you mentioned, I was one of the pioneers of looking at climate and climate change issues going to the regional and to the local scale. Because back then there was the need of getting information at very fine resolution for a number of reasons, of course, for impacts. In particular, I was working on a project where they wanted to know whether climate change could modify the climate conditions in a site that was considered as a nuclear waste repository site in southern Nevada. And the global models were run at very coarse resolution back then. Resolution was about 3 to 500 kilometers. So you can imagine that topography, for example, was not resolved, in particular topography of the Western United States. So we needed some ways of refining the information for global models. And we had the idea of using limited area models that would be run getting conditions from the global models. This had been used in weather forecast for short runs, but it's very interesting because people didn't think that these models could be used for climate applications, because they didn't think you could run these regional models for long simulation times, because at the boundaries there would be too much noise that would pervade the rest of the domain. But I and a colleague of mine thought that we should try anyways, going, how to say, against the normal thinking, you know. And so we tried it. We tried a long run. This was in the late 80s, and it actually worked. We saw that, of course, we had to do some solve some technical issues in the boundary conditions, but we demonstrated that you could actually do it, which was not easy at that time. There was a lot of skepticism towards this technique that we called limited area nested modeling technique, applied to climate, so long runs. It took us a long time to convince people that it could be done. And for me, it was very exciting because, again, it was a new area of research. Of course, again, we had to face a lot of discussions, scientific discussions. But at the end, we showed it worked. And now these regional models are used everywhere. They're used also in Vietnam. We developed actually the first regional climate model, and some of your colleagues in Vietnam are also using it. And now it's used everywhere. So it's very exciting. And I learned a lesson actually out of this that can be very important for young people.
Of course, please do share with us. I'm sure that the younger generation following this podcast are all eager to hear.
One of the reasons why we were willing to try something that people in the field were not willing to try is that we were coming from another field. As I said, I did my work on aerosol modeling. And this colleague of mine, Gary Bates, he was working on some large-scale dynamics issues. So coming from the outside, we didn't have a bias, how to say. I think people working in numerical weather prediction, maybe they had a bit of a bias looking at this because the going thinking was you cannot do it. But coming from outside, we were not convinced we cannot do it. So we tried it and it worked. So this is an important lesson for the young people to, if you think something can work, even if everybody says it cannot, you should try it anyways. Maybe look at things from the outside, from a different perspective. It's an important lesson I learned and I applied for the rest of my career. And then I was involved since the 90s in the IPCC process, the Intergovernmental Panel on Climate Change. And I've seen over the decades how the debate on global warming has changed. Many people think that from the very beginning, everybody said, oh, global warming is caused by human activities and everything was easy, but this is not really true. I remember in the 90s, there were many, many discussions, even within the scientific community about the issue of global warming, especially about the causes of the global warming and its effects. And with time, the evidence mounted and grew. There were more data. There were more models that were being run. And it's only in the 2000s there was a key decade in this debate. Let's say from 2001 to 2010, in which the scientific community finally realized that we were seeing something real, something important that could have a very important effect on human societies. And there was a turning point where even in the IPCC reports, the word unequivocal was used. First, in terms of seeing a global warming trend, and recently in the last IPCC report, also in the attribution of this global warming to human activities. So as you can see, I worked always on very, very exciting issues. People think sometimes, young people think that scientific research is not so exciting, so it's not so adventurous. But let's say, maybe I'm sure it's not adventurous compared to other jobs, maybe like going to the moon or something like that. But in my case, it has always been very adventurous, working on effects of nuclear war, nuclear waste repository sites, climate change, all the discussions. This has always been very exciting. So my message to the young people is that science can actually be something extremely exciting and adventurous, much more than one can think, even if you spend a lot of time in front of a computer.
Yes, and thank you so much for that very invaluable insights and a very useful piece of advice. And now with air pollution linked to over 7 million deaths annually, how do you assess the intersection between the climate change mitigation and air quality improvement strategies? And what are the most pressing regional climate dynamics or feedbacks our global models fail to achieve?
Actually, there is a big intersection between air quality and climate change. And actually, it goes both ways because air quality affects climate and climate change, but climate change affects air quality as well. Um, as you say, air quality is a big killer now. Air pollution, not air quality, air pollution, of course. I think it's a third major cause of death in the world. You mentioned 7 to 8 million deaths per year, and I think many of these people actually that are dying or they're getting sick are in East Asian countries because I mean, I've been in East Asia many times, and I have to say that I mean, these are beautiful countries, but there's a lot of pollution in countries like China, India, maybe Vietnam as well. There's still a lot of pollution because, of course, these are countries that are developing very fast. There's a lot of construction work, a lot of traffic. I could see, and of course, especially in the big cities, the air quality issue is a very important issue. Climate change actually can make air quality even worse because some years ago, for example, with a colleague of mine, I wrote a paper on the effect of climate change on ozone levels. And the higher temperatures you have in a warming world actually increase the biogenic emissions of ozone precursors and particulate material precursors. And so this tends to worsen the air quality problems. Also, one of the effects of global warming is to increase the length of dry periods and drought periods. And of course, this also is very bad for air quality. So there is a big intersection. Decreasing the emissions of greenhouse gases also implies, by decreasing the use of fossil fuels, also implies a decrease in the emission of pollutants, of air pollution. So I think there is a win-win situation. Especially for East Asian countries. I can see, I've seen at least that in East Asian countries, there's a lot of activities towards what we call a green economy. So an economy where, for example, energy production goes from fossil fuels to renewable energies. China, I think, is one of the biggest producers of renewable energies. And this is also done to decrease pollution, I think. So there is a win-win situation where you decrease local pollution and decrease climate change agents. So I think the two go hand in hand. And I also think that when you develop regulations about air pollution, for example, in Europe, we have air pollution standards. These have to take into account climate change. Because as I said, climate change affects potential pollution levels. So at least in Europe, we do this. We also account for the possible effects of climate change. So I think in Asia, probably it's needed. Something like this is also needed. This is actually, the second part of your question is, can the global models actually represent this issue well? This is one of the problems with the global models. I mean, air pollution is a very local issue, is a very regional issue. Global models still at a very coarse resolution. For example, they don't resolve cities. Cities are where air pollution is the biggest problem. And that's one of the reasons why we have developed regional models. Today, regional models can go to a resolution of even 1 kilometer, where you actually see, I don't want to say you see the streets, but almost. You can see the cities, you can see urban canyons. So I think we can get, and regional models now include in an interactive way aerosols. For example, some years ago, we did some studies of aerosol effects on local temperatures, for example, in East Asia. So I think regional models can be very helpful in this nexus between air quality and climate change. They can be very important in understanding and in studying this nexus. Another area where regional models are, of course, very important is capturing the effects of local topography. That's probably the main reason why they were developed, because, of course, local topography affects climate in a very important way at the local scale. And land use. As I said, for example, cities are not included, are not seen by global models, but they affect climate locally very much. For example, the heat island effect. So this is something that can be seen in the regional models and can be studied in the regional models. So there's many ways in which going to very fine scale with regional modeling activities can improve what we can learn about global warming and climate change at the local scale.
And of course, when you talk about the importance of using regional climate models into mitigating the climate change effects and also improving air quality, what role do the cutting-edge monitoring technologies play in tracking and tackling pollution effectively?
Yeah, this is an important issue. One of the main problems in terms of atmospheric chemistry and aerosol modeling is the data that we use to validate the models. Unfortunately, these data often are very local. You have station data, while the models have grids that are kilometers. They're sparse data often, and they're data that have large uncertainties. So it's when you have such large uncertainties, you can say that the model is always good because the uncertainty range is so large that the model is somewhere, sometimes in this one order of magnitude, the uncertainty. So it could be 10 or 100. So of course, the model can be in that range, but I think it's very important that we have to refine, to improve the observations about chemical compounds I think satellite, I think this needs to be done on a regional scale, because as you say, air pollution is not a local process. It's really a regional, if not even a global process, a global concern. But it's definitely a regional concern because, of course, wind circulations move the pollution around. Sometimes we see pollution from one continent to reach another continent. It's not only regional transboundary. So I think we need ways of monitor this at the regional level, and I think satellite data are key for this. Probably the best tool that we have today to improve observations, or to develop a dense network even at the surface, but they have to be, again, not local, but they have to be regional networks. And this, of course, implies a collaboration across different nations. Not only a collaboration, but also exchanging the data. This may seem something strange to you, but today is, data are becoming a commercial commodity. People sell data. But this makes it difficult to exchange it, in Europe, this may sound strange, but we don't have a common climate data set across the whole Europe. Every country, they give some data, but they keep some data for themselves because they sell it. It's a commodity. They say, it took me some money to get it. And I think this is not good because if even in Europe we cannot have a shared common high resolution data set, this may be even more difficult in other areas. So I think the issue of data exchange, of data availability is a crucial issue, is a critical issue at the regional scale. I don't know, honestly speaking, what's the situation for East Asia, if there is a problem of exchanging data between countries. But this is something like actually the VinFuture Foundation can really help, because again, being a private foundation is more flexible, so maybe it can provide some way of catalyzing this exchange of information and creating common data set.
And yes, and now back to what you just said about the context of urbanization and land use changes, especially in developing countries' context. How has the science of biosphere, atmosphere, and chemistry climate interactions has evolved in the last decade?
Yeah, this is a very good question, because these are key issues. In my opinion, in the opinion of many people, in fact, the nexus between cities and climate change is a key issue for several reasons. The first reason is that most people live in big cities, in megalopolis, let's say, and more people are going from rural areas. You know this better than me, from rural areas to big cities, hoping for better economic conditions. Sometimes this is the case, sometimes not. But I've been in many so-called developing countries, in many of these megalopolis, and I've seen how big they are. To me, it's I live in a small city with a lot of green areas around, and so I consider myself quite lucky. But I can see that the issue of cities is very important, because climate change is more of an issue in these big cities, because, for example, the heat island effect can increase temperatures by several degrees, and this can make outside conditions unlivable, especially in a time where heat waves are increasing in number and are increasing in intensity. For example, I'm in advisory committee of Singapore Climate Center, and the single most biggest issue in Singapore is heat waves, because they can see that they have the heat island effect, and during heat waves, conditions to stay outside are becoming very, very difficult. You cannot work, you cannot have your normal life outside during these heat waves that are more and more frequent. So a key issue, for example, in Singapore is how can we cool the city by having urban parks, urban green conditions, and they're very active in this. In Europe also, this is an issue that is, of course, discussed very much. How can we cool the cities by making them more green? There are very creative options like to put small forests on top of shopping centers. I've even seen this. Maybe in Vietnam they already do this. I don't know, but this I think will be an issue for the future. How can we um, make cities greener and less polluted? So more public transport, more electric vehicles, because cities are, I mean, there's nothing to do. This is where most people are going to live. And there is a risk that the environment in cities will become unlivable because of the temperatures will be too high and the humidity will be too high. As you know, if the temperature exceeds, I think, 35 degrees with 95% relative humidity, the human body doesn't cool down fast enough. And you can even die of heat stress. Um, and there have been studies that have shown that in a global warming future, many cities, especially in tropical areas, so I think Vietnam is very vulnerable about this. Many cities will cross this unlivability threshold, let's say. So this is a very important issue that I think cities will have to address in a very important way. Uh, but cities, on the other hand, they're not countries, so they don't have all the complexity of a big country. Maybe a city can be more flexible, can deal with these types of issues in an easier way, in a faster way. And in fact, there are many uh, global network of cities that are getting together and starting to think about how can we decrease emissions, make cities more livable, make cities greener. And I think that's where they can really give a big, big contribution to solve the climate change problem.
Yes, and I think that what you just said is absolutely correct in the context of rapid urbanization everywhere, especially in the developing countries. Cities are really at risk. Earlier this year, we received a report where saying that our capital, Hanoi, is now in the top 3 cities in the world with the worst air quality. And with an emerging economy, some would say that there's an obvious rapid development to which most would think that we have to pay the price in terms of environmental sustainability. So I wonder, what is your opinion on this matter?
Yeah, maybe I can say something about this. I think this is a very wrong perception. Um, Many people actually think the same way that you said now. They think that in order to develop, you have to pay a big environmental price. Um, but this is not true anymore. I think today we have the technology to develop within what we call a green economy. I'll give you an example. Today, electric energy production by using renewable energy sources, so photovoltaic sources or wind energy, is actually from the purely economic standpoint, is costs less than producing the same energy with fossil fuels. In many countries, for example, in European countries, fossil fuels are used because there is state subsidies, not because it's more convenient. So I think in many ways it's a choice. It's a choice that we can make to have a transition. We call it an ecological transition. So having uh, an energy transition to decarbonize the energy system, to green to stop deforestation, which unfortunately is still going on, also in Southeast Asia, but to stop and possibly to start the process of reforesting, to use local resources, to recycle. I don't know what's the situation in Vietnam about the recycling paper, glass, or even clothes. But this is also something that needs to be done to reduce the waste. You know, we waste a lot of things. I was very surprised to learn that today we waste about 60% of the energy that is produced. I saw this presentation by the CEO of British Petroleum, so somebody who knows very well the situation. And the first slide he put was, today we waste 60% of energy that we produce. We waste it either when we take it or when we transport it or when we use it. So I think just having more efficient technologies will really help also the pollution issues. So I think today the equation development equal environmental loss is not true anymore. We can develop in a green, within, let's say, a green economy framework. The technologies are there. We have to choose to do it. Of course, some sectors are penalized by this, but things can be reordered. I think the green economy should be seen as an opportunity for development. To me, the future is a greener future. That's the progress. The progress is not burning more coal or burning more petrol or something. To me, progress is having more livable cities where people can live and prosper. And today, this is possible within a green economy context. It's just a matter of choice. And this is something else that I think the VinFuture Foundation can provide a strong impetus. Because I think, we have to involve the financial sector in this. We have to convince the big financial sector that the green economy is an opportunity and that everybody will be happier if we move in that path. We have to convince the people who can move big amounts of money, big funding to improve technology, on how to go more green. If we do this, if we're able to do this, and the VinFuture Foundation can have a big role, then we can solve the global warming problem and the pollution problem. I'm quite optimistic that we can do it if we choose to do it. Let's put it this way.
It's very inspirational to hear you say that, because I do think that climate change is a long journey. It is a very long journey, and sometimes it is not about seeing the end, but also just about hoping that we can succeed, we can achieve this green future. So reflecting on your decades of work in the interface of science and policy, what gives you hope about our ability to confront climate change?
This is this is $1 million question, you know. Of course, as you said before, it's not an easy problem from the policy viewpoint. I make the comparison with the ozone depletion problem. The ozone depletion problem was an incredible success by the scientific community in providing information that helped to solve a big environmental problem. Because people don't know, maybe they don't realize how important the ozone depletion problem was. In the 80s, when there was a peak of the ozone depletion, I was living in Denver, close to Denver, at 1,500 meters high. So the sun was very strong, and the number of skin cancers were increasing, and And you could stay in the sun for half an hour and already burn. So it was getting, it was an immediate, the danger was immediate. You could actually see it. And the technological solution was there. The CFCs were replaced. And the problem has been solved. Susan Solomon probably told you much more about this than I can. But at least it's being solved. But there were some aspects that made it easy. One was that the danger was very immediate and very easy to understand. Skin cancer increases. Everybody is afraid of skin cancer, so we have to do something about this. The technology was there to solve it, and it was easily implemented, at least more easily than other types of transitions. In the climate change case, of course, it's more difficult because there are very big interests involved. It's a danger that, as you said before, you have to have the vision of looking ahead several decades. Some of the people who are potential winners of the VinFuture Foundation Prize work in this specific issue of how to give value to the environment. I think young people are starting to do this, and this gives me some hope. I also think that the human race is a very resilient race. So working with the nuclear winter problem, okay, you're very young, so you don't remember this, but there have been, well, don't remember, you don't know this, you were born after. In the 60s, in the 70s, there have been times where somebody could have pushed the button and you would not be here. You and I would not be here. The human race could have self-destroyed on several occasions because the human race unfortunately has weapons of mass destruction, nuclear weapons, chemical weapons, biological weapons. But there's always something that makes somebody understand that you cannot do this. I think it's the instinct of preservation that we have as a race. It makes us not make that last step, okay, towards destruction. And I think here the same is happening. And I think this not making pushing the last button will come from the young people. They will become more and more aware that the future is their future. I've done what I had to do, but you still have a whole life to live. And so you're becoming more aware that something needs to be done to improve conditions. You and many young people that I talk to. And so this makes me hope for the future.
And in the spirit of passing the torch to the younger generation of science and also the next generation everywhere, as a global leader in climate science, what advice would you offer to the young scientists throughout this podcast?
Passing the torch because it's something that we also have to do.
Yes.
But unfortunately, we grew up in a different frame of how to think about things. So for us, it's more difficult to change. But young people have a more flexible mind, so they can think in more different ways. So I think the solution will come from, they will think about different future, I think. I think they have more potential to think about a different future. And we can help and we can do whatever we can to help. But the brilliant ideas will come from the young minds, I think.
Thank you, Dr. Giorgi, for such invaluable insights. And I am sure that the younger generation will learn the best from those who have paved the way before them. And it's been an absolute honor to have this conversation with you today. And to our dear listener, this wraps up the episode 6 of the Unveil the Future podcast, as well as the season 2 of this podcast series. And we hope that you find this episode and this discussion very engaging and enlightening. If you like the content with this episode, please show your support by liking, subscribing, and sharing it to your network. And a quick reminder, the VinFuture Foundation is now opening the nomination portal for the 2026 VinFuture Prize. Check out the link below for more information. And thank you for your continued support. Stay with us on our journey to keep identifying and honoring the groundbreaking scientific innovation.